Welcome back to another session. In this session, I'll try to fix that issue which is in my AutoFilterer repository. But before we start, I need to introduce you what is AutoFilterer and how it works. Then we can start. AutoFilterer is a mini filtering framework library for .NET. As you can see, you can define a filter object which inherits from a specific class, or you can implement only the interface of AutoFilterer. It's okay. Then call apply filterer method over iQueryable object, and then you can pass this filter object to this method, and it will automatically generate queries for your entities. For example, you can pass here some properties, for example name, and it will be generated as to lower and dot contains method, and you can pass some other parameters. You can use some attributes, and you can choose it should be equal to locale, or you can use some kind of different approaches. Okay, I moved my documentation. You can see it also supports pagination and sorting. You can pass some sorting parameters and etc. For advanced usages, okay, you can see, yeah, you can say, yeah, this query should be generated as contains, but it should be compared to title and author property of the entity. So this property will be generated with contains method for title and title or author property of entity. Also, you can define it should be and. It's not so useful, but you can use in some cases and. This is a simple demonstration of the original library. But in this case, we have some issue in the thanks for Dennis defining for this issue. While generating queries, we use exactly exact parameter which is constant expression, and it generates something like that. It's not generating any parameter. It generates exactly the I don't use magnifier. It uses exact value, and it has some security issues because you can use the SQL injection can be executed here. It allows execution of SQL injections because the string value is placed here. I know this is not the topic of AutoFilter because AutoFilter generates only link expressions, but there is a problem. You can see it's generating queries like that for now. For example, x.name equals sorry, this should be double equal sign here. This is my bad. Okay, it generates something like that, but it should generate something like that. Filter object.name, it should be parameter, and then SQL Server generates this kind of expression. Sorry, not SQL Server, and framework generates this kind of expression. So I already found the problem. Problem occurs because of here, because I use reflection to get value of property and pass it as expression.constant. It's not a proper approach. I need to use expression.property. That means accessing a property expression. So this is the property access expression, filter.name, instead of writing value in a string code. So let's start. I already found the problem. We need to change something completely. We have to make a breaking change because all the logic built on top of the reading value with reflection, but in that case we won't read the value. We pass only expression, only property expression to other objects. What I mean, because you can see there is a operator comparison attribute. Also, there is some filter based object. There is some attributes. Before we go, I can show you how it works. As a first, we have a filter base object. Filter object. I don't like it. I will use, yeah, dynamic size. Yeah. We have a filter object. How can I write text here? Okay. What filter base? I don't like it. Add another topic here. So this is filter base. This is a class. Let me write here class. And this class, if you inherit from this class, or much easier one is iFilter. This class has some properties in it. Has some properties on it. This is iFilter class. Okay, I grouped them. And it has some properties. It has some property, and these properties will be generated as queries over entity. But the filter class, the iFilter class itself generates queries. Okay, this is the first logic. The logic is included in the class, but in some case, our properties can be filterable type. So ifilterable means, for example, I have some custom types, not string, datetime, boolean, integer. There can be some custom types such as range. Let me show you in the documentation. Yeah, here range. You can see there can be some primitive types, and also there can be some custom types like range. It means it includes minimum and maximum value in it, and you can pass a primitive type to range, some I comparable type to range, and this range has its own logic in it. And the filter base object, this is also filter base object, and the filter base object don't execute the default logic and executes the range logic from the object itself. So this is a case. Also, there is some more case. Oh, sorry, I filterable name, let's say. Need to make a little bit bigger, but I couldn't do it. Okay, this is another logic. I will make it this bigger too. Okay. Also, we can have some attributes over it, and you can pass some parameters. So this is another filtering option here. So we have three types of filter in the AutoFilterer. The first is filter class itself, and filter class itself generates queries for primitive types. For example, in that case, string, integer, boolean, and datetime, and maybe time span or whatever you have. It will generate queries over these primitive types, but there can be some range or any other type which inherits ifilterable. So this logic can be executed. Also, attributes overrides it. For example, in the filtering, let me find it. Operator, for example, operator comparison. You can see, for example, we can go with string. You can see there's a string filter option. This is an attribute and includes its own logic in it. So if there's an attribute, filter-based class will execute the attribute. So we have three level of filtering execution level. So I will start at the beginning, which is filter base. I filter, but I will implementation is filter base. So I will start with filter base and change all of them. Let me sure the repository is updated. Yeah, let's open with Visual Studio. close enough. Yeah, there is already filter base here. You can see, let me make it bigger. Yeah, you can see filter base implements iFilter. So if you go navigate to iFilter, you can see there's a build expression method. This is the main method which generates expression. And there is another method for apply filter too. It also a proxy method makes the usage much more easy. You can pass an iQueryable collection here, and it will automatically apply this filter to that collection. So you can see in this implementation. Let's go the first implementation here in the filter base. You can see this is a proxy implementation. This is a proxy method. Otherwise, you have to use entire filter logic like that. You can see this calls the build expression method. It is here. After builds the expression, this is expression, pass this expression to where, you can see, converts this expression first lambda, and then passes it to where operator, where extension method. You can see it passes everything to where statement. So this is a proxy method. I will pass it. Everything happens here in the build expression. You can see there is some reflection operation. We have entity type here. You can see it is passed from here. You can see this is, we already know the type of entity, and we have this class is also filter object itself, and this type of this the type of this class means filter object type. So we have directly get this type of class and continue to use. In that case, you can see we get properties of this class because this is filter object. This class has properties to filter, and we want to use this class properties. I know this is reflection. We can use some caching by types, but it's not so big deal. We have already benchmark tests, and there's not much difference. So we don't use any caching here. It works really fast. It's okay. For each filter property, this is the where the problem begins, because with this line we get the value of a property and use that value to compare in the queryable collection. We pass var expression. We pass this value into a var expression, and this occurs this problem. You can see when we read the value and pass it to the lambda expression, it will return like that, but we don't want that. We want this usage, so we have to access the property of the filter object, and it should be something like that. So we don't know, we won't know the value, we will just access the property. So in that case, I don't use this one, and also I change entirely and where the value is used. Also, I refactor the names of fields, variables. So you can see it pass first attribute, and then the entire execution tree will be worked. It finds first attribute, and attribute finds filterable type or not, and then everything works. But the first endpoint is attribute in the filter base. So before we go, we have some tests. Let me run all the tests first, because I don't want to break anything. So I need to be sure all the tests are running and passing. And I will start with adding another test which covers my current test case, and then I want to try make it successful. Okay, what happened here? Ah, okay, it's filtered. Okay. So what does it mean? They are not run tests. Okay, run them. I think there's a problem with this tests. We used to cannot run them. What is the problem? There's inline data, there's theory. Yeah, why it shouldn't? Okay, it says it's passed, but I'm not sure. Okay. Okay, just continue. In the test project, I'm not sure how can I start. Maybe I can add another method for the first one is can be filter based test. Yeah. Ah, this is already filter based test. Okay, which one is the easiest test? Which one is the most basic test? Apply filter, expected. Is too complicated. I'll go with compare to attribute. Yeah, this can be a good point of start, but let's go to filter based attribute, not attribute, sorry, filter based object, and I will add something like that, yeah, at the end of the file. And first, what is the book filter? This is too complicated. Is there any much more basic filter? Use a filter base. It's so complicated. Filter with nullable property. It might be useful, but I need some simpler. Total views. This can help, not, but it's range, string filter, book filter base. Okay, this is the easiest one. Okay, I will use this one. And let me get some copy. Yeah, here, this is the entire test package. So we'll use property expression. I will rename later, but this is good for me for now. So what is the problem? Rate limits. Okay, this is because there is some different data here. Okay. Yes. What is the difference? Okay, this is still it seems okay because the name is different. Okay. Okay, now it's okay. I have a filter object. Okay, that finds some data. Okay, it's okay. But I need some string, I think, string field. Okay, I will go with custom object here. Okay. Let's say I have an object and I will use the string field here. Given name. Okay. I will use the filter given name. And I don't set anything. I don't add any property, I don't add any custom type, and this is really simple class, and I will use this class, let's say A. I'm not sure, maybe I can use the first element of the entire collection. I want to filter it, okay, because it will generate equals filter, because I don't add anything string filtering options like ignore case or something that things and ignore case. I don't add anything. It will use equals filter, so I just use the first data of given name. Okay, it will apply filter unexpected query. Yeah, I can use it. Given name. Okay, I don't compare count. Instead of, I will use maybe to string, but I'm not sure. But this won't work. I need to get expression. Maybe we can compare expression. Okay, let's set a breakpoint here and check what happens. Okay. You can see in actual query, yes, you can see, but you cannot see right now. How can I show you? It's so small, but okay, I'll make zoom here. Okay, you can see here it generates a lambda expression in var method. You can see there's a x dot given name equals a string, a static string field, but I need something like that value, another value which comes from another class, another class property. So right now they are not equal. I'm not sure. Did I capture magnifier or not? I hope it is visible. I can use the watch here. This is actual query, but I don't know how to make it bigger. And this is properties, but I can use toString here. toString. Here my expression. You can see. Okay, I can check the expected one. Yeah, there is difference because they are not same. Because one of them uses constant and one of them uses property expression. So I need to make them equal. So this test will fail. Yeah, this failed right now. I want to make this fail successful. So our case is ready. Let's start development. We will go with test-driven development. So I don't want to read the value of this property. So I won't read it. I'll just remove. I couldn't do it. Yeah. But before I remove, I'll get some copy from it. In here, I need expression. Let's navigate back my hint here. Yeah, expression property. I need that. Maybe I can get, but I don't use yeah, constant of this class. Okay, this is makes sense. Okay, it worked. Interesting. But before we go, while creating an expression, for example, we can use member access. We can create a member access expression. So we can access property or field or constant field or whatever you want. You can make an access, but we won't use it. We already iterate in properties in here. So I will use property access here. Property or field is also another expression, but I will use just property because our target is property at the end of the day. So the first parameter, also the both parameters are same. You can see there is expression and second parameter is expression. Also there are a lot of overload here. You can also even use property name or whatever you use. In here, I'll pass the entire object. So let's create another expression here, expression constant, because this is a constant value here, this class, because this is, in that case, you can see the case here. In that case, the filter is our constant class, constant filter class. So for accessing this filter, I will use constant this. I hope it will work. I'm not sure. We will check again. And we have to access the name property of this class. We can pass the name of the property, but we already have property info of this property. We will pass this variable to this method, because at the behind of this method, I'm not sure, but probably it will use reflection to get the property info again. To prevent this, I will just pass the property info we already have. So this should work, but it's not the problem isn't solved, but we can add breakpoint here and check how it's going. But where was my tests? This is not here. Okay, I already pinned it here. Let's debug it again, because I have a breakpoint at the filter base. It will hit. Okay, let's continue. In the, yeah, you can see the expression here in the dot given name, like exactly same in my expected situation, but it won't work because this expression is used as value at the end of the. Maybe I can continue the execution and you can see what is the problem, because I will change entire logic. I need to change the entire logic because all the execution logic that I told you here, they expect the value of the filter, but we will pass the expression. We will change parameter of methods. You can see there I cannot do it, but yeah, you can use the watch tab here. You can see uh, it is not what I expect here. Yeah, because yeah, this is what I told you. You can see in actual query there are no query, because probably they couldn't match the types, and pass the execution is finished because they couldn't match anything, and they just pass instead of throwing exception. In it's configurable in the library, but it's configured ignore exception by default. Probably there is an exception and it didn't generate any query. So by the way, the test will fail. So let's continue. In the val, I will change the names. This is not val, this is not value also. This is property, not property, filter, property expression, let's say. And the name of the variable itself should explain itself. So it's if it's not okay, I think we need to get value again, because uh, if the value is null, we have to ignore it. We have to continue, or if there's a ignore filter attribute. So we need to access the value again. Let me copy this. Okay. Yeah, we need to read value first, because need to know if it's null or if it's maybe default is much. We cannot use default because 0 is default value of integer, but I'm not sure. As a best practice, I offer you to use nullable types, but if you don't use nullable, okay, null check is much better. I will use multi-line if statement. Yeah, let's say, okay, sorry. Let's say this is value of filter. Let's say this is filter value. Yeah, because we are in for each, it is also one single property value of filter, but it's understandable. I will go with that name. We have expression. Let's check where the filter value is used here. Yeah, you can see it passes this value to attribute. So we need to change build the expression for property method parameter here. This is a breaking change, so I will release this is as a major version. So we won't use filter value anymore. We will use filter property expression. Also, we don't need to pass. We already pass filter property and target property to the attribute. So this can be calculated. No, this cannot be calculated inside the attribute because attribute cannot know this class. Attribute cannot know what is the filter class. So this, where is it? Yeah, this should be calculated in here. So I will pass expression itself. Okay, this is much better. So since it is object, it allows me pass this parameter here, but this parameter type is member expression. Maybe we can use expression instead of member expression. I'm not sure. Maybe can we use something else? Maybe okay. Let's go with member expression. If it so if limit sus, we will change again. So it should be member expression, but this method should come from interface. Okay, there are 43 references, but let's start with this one. As I told you, this is a filterable type. This is also attribute. So this should be changed. This should be member expression. And yeah, let's update the interface and get all the compile errors and then fix all of them one by one. This is member expression. It is not value anymore. This is filter property expression. Yeah, the name is long, but yeah, it is better for understanding. Not object. Member expression. We don't need summary. What it says, you can have a complex stuff. Okay, okay, it can stay. It can stay for documentation. Yeah. And yeah, here one of the implementation. Update the name. This is also abstract class, abstract field, attribute class. Let's go to implementation of this attribute. Yeah, there are a lot of implementations. Let's start with the easiest one, compare to attribute. Yeah. Compare to attribute accepts property name in the usages in the documentation. You can see where is the property name mapping. Yeah, property name mapping. You can use multiple property names to match. You can see here it accepts multiple property names and applies this filter to multiple fields. So let's update this method change here. I'll make it a little bit smaller. I hope you will see clearly. This should be member expression, and I'll change the name. You can see there's another build expression method here, and it also accepts because well, we changed in the base class, and it's changed, and you can see it accepts member expression. Yeah, we have member expression, and we can pass complete the same parameter for building expression. So this is easy because this method don't use the expression directly. It passes. Also, it decides which filter should be executed and passes all the parameters to another object that generates filter. It only decides which filter will work. It doesn't generate any expression, so it's easy to apply the changes here. In here, there is a build expression method here. It accepts member expression again. And do we have? No, we don't have, because this is a build default expression. It should accept member expression here. This is a custom method. It has only one reference. This reference is here. If there is no if there is no if, filter to apply, it will automatically apply default expression, and default expression is equals expression. If value is a filter, it checks the type of value, but the type of value means a type of filter property also. We can check from property info because reflection is so strong. It keeps all the data in it. Filter property type. If the property type is, I cannot use is, I think here, because if I use is, it will check this type of property, and it is type. It doesn't work. If it is type of I filter, this will work. Okay, we just fixed this. If it is collection, okay, it will work. Filter property type is right. Yeah, okay, this will work. Yeah, you can see this checks target property type, but yeah, this is right. This is right because the filter object can have a singular property type, but you can apply this filter to a collection, and it automatically creates contains method. You can see here. Let me find array search here. This is the logic. You can have this singular enum value here. This is not array. This is not collection. The user can send one of the status from the client side, and your entity can have any single no, this is not. This is the opposite one. Client can send multiple publish status in the book filter, and in the entity you can have only one single status. It will get all of them. It will add contains and search all the sent one. You can see this is not what I told you. It might be comments is something like that, but not this one. Okay, it's a work in progress. Not customization. Maybe I don't have operator comparisons, performance, migration guides. Okay, I don't have the documentation of it, but if you send, for example, if the entity have a value field here, and if your filter class, let's say my filter base, if your filter class, okay, let's make it array and say values, and if your filter class has value like that, in that case, when you apply filter to this entity collection, it will automatically create a var expression like that. In here, let's say this is in a filter variable, sorry, x values contains filter dot value. It will generate something like that. So this is this logic. If the entity property is collection or array, uh, automatically applies this expression. So this is the logic. This is correct for checking entity property, but we will check filter property here. So this will work. This is correct. So let's continue. It says filter. It calls filter dot build expression. So what is filter? Okay, it was checking if the class is a filter. Okay, this is for nested execution. For example, you have multiple level entities like that. You have block, and block has a comment collection in it. So you can have two filter object, one for block and one for command, and you can use this comment filter DTO in your block filter DTO and use the same name with this collection. When you do that, it will generate nested queries. So in that case, your filter object property type is another filter base, another ifilter. So this is the logic. So we need to access this property of filter object. So in that case, the same logic exists here. We need to add an expression for it. Expression dot property, not all field, it's exact property, and we will access target property, but uh, yeah, we need to access the original object. This is attribute. I cannot access, but do I have this here? I check. Okay, okay. I have already an expression here. I will access another property over this expression. So like that. From this expression, as I told you, there should be something like that. This is filter property expression. We will put this expression in the right side of this expression. But in that case, I need to access under, let's say this is comments, under something like that, yeah, or maybe single comment. It's because the collection is separated in here. Let's say it has single comment and name. I need to access this one, but I need to access this one over this one. Also this expression, this section of expression. So I can use this expression for accessing this, and I will access a property over this expression. Also this is name. Also this is the expression. Wait a minute. Okay, this logic is correct, but I need to see the original version of it. In the original version, it will access the filter object itself and execute build expression. So at the end, we need to access access uh, entire filter object. We cannot do it with expression because we just call physical method over it. Okay, filter property, but filter object. Maybe we need filter object, but the method parameter is going to both. Maybe I can create a package object that contains all the context objects, and I pass this object, but I'm not sure for it. Let me check. Okay, it sends here and build expression. Build the proper expression. Okay, we pass memory expression here, but it doesn't help us. But I don't know, maybe I can access the... No, I cannot access the right side and left side. We cannot access also. I didn't expect that. Memory for... Here. Look, I'll change something much in deeper. I'll add, yeah, let's say expression build context. Yeah, we need that. Uh, while making parameter changes, it won't be a breaking change anymore because the method sign won't be changed. So this is a good approach. I will move all of them in here. So before we go, let's go back our filter base. Where is the filter base here? Yeah, build expression or property. In here, where is the original method? Build expression body type. Okay, that's okay. Where is our endpoint? Here, build expression for property. So this is our entry point. It uses build expression, build default expression. So this is single method. Compared to attribute and filter based attribute. In here, filter based attribute, we already pass an expression. Okay, let's go back. In the expression body, this is compared to attribute. We pass exactly the same parameter here, but all the problem starts while building a default expression. So we can maybe ignore it, but if we ignore, all the tests will be broken. We cannot pass this kind of thing because this is for nested execution. So let's start refactoring with build expression. Okay, we'll go one by one. Let's go to filterable type, build expression. I will move all the parameters to expression with context, and this is our package. Let's say it context. Okay, I will create a constructor here, put all the parameters here. Okay, all the using statement is okay. So I don't want them one by one, but probably we'll do it one by one. Okay, assign a property, assign a property, okay, assign a property. Okay, all of them, all of them are required. Also, I have an optional parameter here, filter object, or just filter. But it doesn't explain it. Okay, filter object. It's much better. But in that case, did we know the type? Yeah, we know the type. We can pass here I filter. Yeah, always going type safe is better approach. Yeah, we can go with type safe. We can add another property here, but it is nullable. It's optional. Ah, the nullable feature is not enabled in this project. Okay. Okay, this is uh, much more useful. But I think we have too much build error. Let's see what happens. I will go one by one. I'll just start again at the beginning, at the filter base. You can see build expression for property. Yeah, this is a single method, but I will go one by one. So in here, we don't need to pass all of them. So let's create a new. I know this method doesn't accept the build context right now, but I will refactor it. Let's pass parameters correct at the beginning. Expression build context here. I will wrap it to new line because we have a lot of parameters. The first one is expression body. Expression body is body parameter here. I think, yeah. Target property we have exactly same here. Filter property. Expression we already calculated the expression. By the way, if we send value again, like at the beginning, and if we have filter property, we can calculate this expression always because we just sent this class as a filter object, and this can be calculated in anywhere. So we can ignore this entire changes and can go easy. Let me think a little bit more. It doesn't work because we didn't send this class, this object as a parameter. We just send value. Okay. Okay, we will go with this context. And filter object is this at the moment. The type is iFilter. Yes, this object is also iFilter. So what is the problem? Yeah, it doesn't accept build context. We will refactor it. We go to this method definition and change the parameter to build context, expression build context. What is the problem? Okay. In here, we have filter property in context. We have expression body in context. I will make it wrapped for more readability. Target property, we have all the parameters in this context. Yeah, member expression. Sorry, what was it again? Okay, let's continue. What is member expression? I will check it from here. What was the original? The original one is target property, expression by, and value itself. What was the original again? Expression by, target property, filter property, value. Okay, what is the next parameter here? Okay, why did I do that? We already refactored it. We just passed the entire context. So yeah. Also, this accepts the entire context. Yeah, this is much more useful. Yeah, this method doesn't accept the context. We just refactor it. But before refactor, I just duplicate this line and comment the first one because I need to compare the old one. What is the problem here in the build expression? Okay, we didn't change attributes yet. Okay, I will do it later. I will go in the flow. I'll this we will come this part, not but not yet, not now. This should accept the entire context here, and we will pass context without changing it. Yeah, and here filter property can be accessed inside context. Filter property, okay, property type. Also, we have the filter object itself. Context filter object is iFilter, like at the beginning, like at the original. Let's say filter, and we can call filter expression over this object, but it accepts entity type and expression by. Yeah. Context, target property and property type and parameter. What is parameter? Expression by the entire. Okay, it will work nested. Okay, we don't have to do uh, anything more. Yeah, if it's assignable from, what is target property type? Okay, we will use context dot target property type. It's going to be some manual refactoring, but sorry for this session, but we have to do that. Context dot target property, yeah, accept changes. Also, build expression doesn't accept context, but it should. I'll come back later because this is also another attribute. You can see this method is inside correction filter attribute. So I will pass. I will come back again. If filtered property type is filterable type, if it's another custom type like range, like in this document, not in this document, like let's say working with range documentation, if it's not a primitive type, if it is a range or something equivalent, this execution, this if will be matched. Let's say context dot filterable property is filterable type. I need to see the original one here. If value is filterable type, I will execute the method on it. Okay, we can use value here again. Context. Value means filter object here, not filter object. Sorry. This is uh, value of the property. We already calculated the value of this property here. Whereas this is filter value. Maybe we can include it inside context. Where is the context? Filter context here. Expression build context. But I'm not sure, it is not always present because we don't need to calculate all of it. But at the beginning, we already access, and I don't want to access it again and again with reflection. So I will include it inside my expression build context. So let's say uh, filter, but I cannot use it. uh, Expression build context. This expression build context is generated for each property. If it's generated for each property, yeah, it is generated for each property. So I can use property name here. Yeah, this is good name. Assign it to a property. Sorry, not property name. Sorry, property value. We already accessed. Also, we can already access with uh, filter property info and filter object. We can access this value, but I don't want to access again and again with reflection because of some performance. Uh, because I don't want to. Uh, some, I don't want to access with reflection for each time because performance concerns. Okay, now we can go on. If context dot filter property value, we can use filter object property value. This is good name, but it's too long. I'm not sure. Filterable property. The expression should accept the context, but in here I think we need to generate another context. Let me think a little bit more. If we use the same context, no, it's okay because the build expression will invoke this method again, not this method. Where is the original method here? Yeah, here. Invoke this method again if there is no custom implementation. And if there is a nested usage, it will automatically use this this case will be executed, and it will automatically calls build expression again, and this build expression implemented in iFilter base, it will automatically generate a new expression here. So there's no new expression creation required. Also, we can pass property value here. We have filter value. Let's say filter property value. This is much better name. Okay, go back our not test. Where is my attribute? So I can pass the same context here. I hope it will work because we pass exactly same values here. We don't create any expression here. We don't create any expression here or property or access anything else. We pass exactly same parameters, so this should work. Let's pass context. There's something else. Filter property type is array. We have filter property inside context. Filter property type is array or target property type. Let's. I'm not sure. I need to check the original one because one of them checks filter property and other one is okay is not. Sorry. Let's don't change the logic. We just pass the correct parameters, and test will tell us if we broke something or not. Build expression should accept context again. All the parameters same. Let's pass same context. We will refactor it because now it doesn't accept context. In here we pass. Let me check again. Yeah, we pass context here. So as I told you, we have to go back to attributes because this is attribute. We have to pass context. Build for property, it also accepts context. But let me check if we use custom expression body comes from parameter. Target property is changed. Filter property is changed. I cannot do that. I can do something like that. Yeah, we don't have a context here. Okay, this is also an attribute. Okay, I will change this parameter and everything will be changed. So let's navigate to base object here. This is an abstract class for attributes. Also, it is filterable type. We already changed this, but we didn't implement it in classes. So let's say there's a expression build context. Sorry, I just opened insert mistake. Okay, we updated abstract class. Now we can go back to implementation. So this is compared to implementation. In here, we need to pass context here. What is it? Expression build, sorry, expression build context. Let's say it is context. So in here, it iterates all the property names and builds different expressions for each property. So we have target property inside context. Also, it manipulates expression body, but it is correct behavior, expression body, but it is read-only. Uh, it can be internally set. If you customize and extend this library, it should be settable, but I'm not sure. Yeah, it can be settable because we return. If it's not settable, we can create another variable here and return it. I think it is much more better because I don't want to uh, manipulate the original variable here because this context is used in multiple levels. So if I manipulate the original one, maybe I can broke something. But if I create even a new variable here, expression body, and if I set this expression body, it doesn't make sense because both of them, this property and this variable, references the same object in the memory. So it doesn't make sense. Doesn't make sense. Let's go with that. We will decide his usage after running unit tests, because not this is not good. Check this, not explanation. Make it better is uh, decide to use whether itself or use a local variable expression body or not readability. Okay, I'll decide it later after running a unit test. Yeah, in here, in build expression, I cannot pass exactly same context here. If I don't pass exactly same context here, it prevents all the problems that I mentioned. Because you can see expression body, okay, same. Target property is different here. If I change the context target property here, I can manipulate the original object, so I will create a new one instead of uh, instead of changing the original one. So let's create a new context here. Yeah, expression build context, expression by the same, target property the same, filter property. Um, filter property it didn't change. Am I right? Target property changed, filter property same. Then we can use context dot filter property. And we can use context dot filter property expression. Also, we have to pass all the values from context, like filter object, filter object, and context dot property value. Because I just want to change a single property, but I don't want to update the original context, so I just created new context because the new query is generating here. In here, the same logic applied here. Filter property, filter expression, but all the same, but only target property changed. Maybe I can create this instance once and use in both of them. Pass this new context here and to here. Okay, new context. Okay, I can make it in a single line. Just good here. I'm not sure. This is better here. Okay. I created a new context and pass it. Okay, everything seems right. Only in this class. So let's go to other implementations. I'm not sure. Can I run unit tests right now? Let me check. Yeah, there are some compilation errors. Okay, let's continue implementation. Let's go array search filter first. Okay. The build expression doesn't get such properties. We have context. We have expression build context here. And let's say the parameter name is context. Now value is collection or collection is empty. Return true. Oh, what about running the same expression, but it adds at the end of the expression? So it doesn't work. Okay, we can just return true. I don't change the logic in this refactor. Okay, I don't touch this true, but I didn't like it. Make it better. Maybe return null if I, yeah, when null is returned, we can ignore adding. Okay, it should be ignored and combined with another expression. Okay. Expression better, yeah. A value, do we have a value in context? Yeah, we have value in context. Context dot filter property value, yeah. If target property, we have target property in our context. Property name. Do we have anything? The original expression value, yeah, I have. Sorry. Target property name. Why we need name? Because we create a, yeah, but look, I did it. I did it in here. We are generating a property access expression here. Like at the beginning, I changed. We can pass property info here instead of name because it already uses reflection to access the property. Let's say context target property. I think this is enough. Uh, I'm not sure. Let's pass name to prevent future problems. I will factor later. It should be exactly same, but I'm not sure. Just leave it the old way, old logic. The constant is value. Yeah, there is another problem. We don't have to use constant because when we use constant, it will generate the same query here. If it's string, it will be rendered, it will be used, or it will be, query will be generated in quotes. I don't want to use constant. But what is value here? Uh, I will create a property access here, but value means I need an expression dot constant of filter object here. Yeah, constant of context dot filter object and access property of that filter object. Uh, Property of that filter object is yeah, we have in the context dot filter property. Yeah, this filter property. Okay, we have to call contains method over this one because this is collection. If it's not collection, we will return. If it's collection, let me make it more absurd, make more concrete, more understandable. Let's make an example here. Let's say we have lambda. Yeah, something like that. Filter object property. Not this one. Yeah, filtered property is a collection. Let's say you have, yeah, in this logic. What is it? Where is the documentation? Yeah, this logic. What is it? Array search. This is array search. And you can see the entity has a single object here, like publish status is an integer value, it's an enum, integer value, and your filter object has multiple data. In that case, it should generate contains method in here. Let's say not x, filter object. What is the example? Let's say status. Filter object status. Also status is array. It is array, but the name is status because uh, it should match with entity name. You can use compare to attribute and you can make it plural and use compare to attribute to match this property, but by default it matches with names, so it's okay. The status is also array, but you can use contains on it, and x dot status. It should create something like that. It should call contains method over the first one, because contains method is expression method and gets first property as when you hit dot, it will send this one as a third parameter to contains method. This is how extension methods work. The first parameter is the filter status itself. So this should be filter object and filter access property. Yeah, this is correct. And the second one is expression body. Expression body comes from context. Expression body. And target property name. Target property name is context target property. Yeah. This should work. You can pass property info instead of string name. This should look better. Yeah, both of them is property access right now. You can see filter status is property access, right? X dot status is property access, so it should work. Yeah, this is a good implementation. Let's continue. Collection filter attribute. This is the opposite one. In that case, your entity has collection. In the entity framework, it can be nested. How can I guess this kind of things? Your block entity has commands in it, and yeah, I already told you this one. This is the case. Let's start with applying the refactoring. Build expression, build context. Let's say context. We have value in our context. Let's say context dot filter object value, filter property value. Sorry, is if it's another filter. In that case, you can see this block filter is a I filter, and it has another I filter. It has another filter base in a properties. You can see the comment is another filter base. So in that case, if the value is another filter, it will call it another build expression method, and it will be work in nested. Target property, yeah, if context target property, just create another expression here. Let me refactor a little bit for more readability. Parameter okay, we already used x, we can use a, but if it is nested more than 2, a will be used multiple times. So let me show the example. In the where expression, I already started with x. Let's say x focuses dot any, because the opposite one, we won't use content, we will use any and a. And if there is another nested filter object, we cannot use a again here. So this is the problem. We have to use a2 or b and then c and then d. The same name won't work, but this is not the current problem. I will add another test case for it. Change parameter name according to nested execution level. This can be another problem. So this is inner lambda. Okay, we created another property access here. Expression body. We have expression body in our context. Target property. We have context of target property. Again, I don't want to use string name. I just want, but this is some other refactoring topic. I don't touch the entire logic here. Logic should stay same, and then we can refactor it. And expression body, we manipulate expression body again. Should I create new one, or okay, I will use the same logic here. I know it doesn't make any difference, but I don't want to add a setter for this recovery, because after we return, it will generate new context. We already generate new context in compared to attribute, so uh, it will generate another expression with this returned value. Not expression, sorry. It will generate another build context with this returned value. So I don't want to manipulate the original one, but in that case, they reference at the same in the memory, same object in the memory, but I don't want to add a setter for this property. We will see. We will see how it works after running the tests. So let's continue implementation. We already did compare to attribute. Here we already created a new context, as you can see, for each property. So yeah, we don't have to care about it. I think like that. I hope we don't need to take care about it. So ignore attribute implements this expression, but it don't do anything because it is, we don't have to override it, yeah, because it's just markup attribute. But so I think it's abstract. Yeah, this method is abstract. Okay, let's implement it. Return context expression by. Okay, let's continue. Filtering option. What is it? Operator compression. Yeah, there's some work in here. Build expression. Okay, we don't have this. We have expression build context. I couldn't write it. Expression build context. Let's say context. Now we create another property access here. Yeah, I don't want to use constant here again. What is param? Equals param. Yeah, I will. Okay, this is the same problem again. Let's start fixing it. Start with fixing it. And context dot target property. I don't change. I really want to remove that name, but I'm not sure. I will make this refactoring later. So this is another problem. I don't want to use constant. I just want to use property expression like that. Property expression for value. Value. I already know the value, but I don't want to use value because of these concerns. This is what we fix right now. We don't want to use constant like that. We want to use a property access like that. So which property we will access? The first parameter is again expression constant, but constant of filter object. Sorry, constant context dot filter object. And which property we will access? We will access the context dot filter property here. Yeah, filter prop. Let's say filter prop. Okay, everything worked. Is null target is nullable? Yeah, we can do it. Context dot target property. Context dot target property. Okay. Accept the refactoring. I think this kind of suggestions come from IntelliCode, not in Copilot. Okay, that's for caching. I will use the exact same attributes for all the time. I just calculated this performance gain with my benchmark test. Yeah, this makes really difference. So I'll just access the static instance instead of creating a new ones always. So if it's null, I need expression body. I have expression body in my contacts. I have target. Yeah, the suggestion. Yes, suggest here. Yeah. Okay, change both of them. Target property, expression body, equal. Is there any constant here? Constants. Constant null because I want to compare if it is null. if it's not null. Okay, not unequal. Okay, okay, that worked. That works. String filter attribute. So we need to careful here because all the issue comes from string filters here. You can see field expression here. Yeah, we will refactor it. There is no such parameters here. We will pass expression build context. Let's say context. Here context, we can access this kind of properties from context. I expect suggestion here. Okay, I can make it myself. Great, that makes me sad. I hope suggestion here again, but no, sorry. Do we need value? Let me check. Will expression with comparison with expression without comparison. Where is this method? Okay, this method can stay with primitive types. Also, this method can stay with primitive types. Okay, I don't change it. Context dot, sorry, context dot value, context dot y. Okay. I don't like this kind of if statement. I will use the block statements. Yeah, it braces. Yeah. This kind of blocks are much more readable, I think. I used to use the old one without braces, but they are not maintainable, I think. This is much more clear. No need to change anything here. Maybe there can be some changes. Let's check if there's a constant usages here. Constant. Yeah, constant value. Yeah, there's a. This is the where problem begins. I don't want to use constant here. I want to access property. So property expression by option. I will pass. I think I will pass the context here. Yeah, I'll pass. Expression build context. Let's say this context. Expression body, we can already have expression body inside our context. Property name, we have context dot. What is the property? Entity property, I think. This is target property, I think. Yeah, target property name. And I will create here expression dot property. Yeah, I want to access property of the filter object. The first expression is expression dot constant because I have constant filter object at my hand. Context dot filter object here, and I want to access context dot filter object property. Filter property, and we have already expression. I'm not sure what it says value. Value already comes from filter property. The same value. Okay. Okay, I don't need to generate it again because the context already contains that filter property expression. So this is the what we use. Let me find setter here. Where is the right axis? In here. Okay, we don't change anything. Where is the original one? filter primary value, and filter primary value is, oh sorry, expression. Filter primary expression is already the same thing. Filter primary, okay. I don't need to calculate it again. Where was yeah, here? Filter primary expression, but yeah, I can cast it to expression, or I can say this is an expression array. Okay, because types mismatch here. You can see this is member expression. This is only constant expression. The types are different, so this will solve the problem. In here, I can pass the context itself. Also same for it. Expression with context. I'll copy this one. Pass the same parameter here. Let me check, is there a constant here? Constant value. I don't want to use that. You already know it. I will use context dot property expression. Yeah. I'm not sure, maybe the problem can occur because it's not expression array. Okay. Let's see what happens later. Context dot expression array. Context not filter, target property. Yeah. Because this site is filtered, this side is target. Okay. Okay, I think everything is done. Let me put it again. Okay, there are some errors still. We miss some attributes. Okay, let's check again. Is there constant here? Yeah, there is constant. I don't like it. We don't use constant here. You already know it. Context dot filter property expression. Yeah, we can just access them from context from our context. Yeah. Let's go operator filter. Okay, we missed it. Why? There's no reference finder for them. Okay. This is for numeric types. This is for structs, which is for I comparable types. This is not for string, but less than, greater than. Yeah, I can refactor it. For filterable type, we already changed that method, but we didn't change the implementation. Let's start from here. Build expression. I think it gets context. So now we need to change something. We need to change something. Let me explain it. In that case, there's a lot of properties here. Let me show it with an example. For example, the client sends something like that. Let's say h dot mean. Let's say 18, and at the same time h max 30, and the query should be something like that. X dot h should be greater than equal. Sorry, not max min. This is, for example, greater than and lesser than. Sorry, lesser than. This should render something like that. Filter dot h dot gt and x dot age lower than or lesser than filter.age.lt. This kind of query should be generated. So in that case, the value is changed. We can use operator comparison attribute. I think this itself, not itself. How we did implement it? Here, building context, filter probe greater than equal, filter probe. Okay, I need to create another context for that for each of them. I don't want to create, but it should access filter.age.lt instead of filter age. Expression value will stay same. Target property will stay same, but filter property has to be changed. Okay, create a method which does it. Expression build context for what is the value type? It's just t. Okay. Let's pass the original one, original context. Let's say original context, and let's pass t here. T, but I don't want pass t the value itself. Just want to pass the name of property, because I want to write exactly something like that. I don't want to get the value of 30 here. Sorry, yeah, value of 30 here. We can write value of age.lt, or we can write filter.age.lt. Since it is already struct here, there cannot be a SQL injection like a string. So we can continue to use value like that instead of filter.age.gt. It will use the value. It can be okay. Combine it's not null. Greater than. We can use constant here, I think, because this is the best way, I think, right now. Operator comparison attribute. But this attribute, okay, if you go back, this attribute uses properties that it doesn't use value. We can pass property. Where is property? We can pass property as constant because it is expression, I think, but it's member expression. Okay, it generates expression here. Okay, you will refactor it. The first usage I told you. Okay, okay, we'll create another context and manipulate it. Okay. This is value, but we won't use value. I need to access. I need to access property. Property name. Okay, we don't have any reflection class and member info, so we can pass name. Okay, let's finish this method first. We have let's return new expression. Original context. The name is too long. I will say C and rename it later when I finish my job. c dot expression body, c dot target property. Why my IntelliSense doesn't work? C filter property, c filter property expression, c filter object, c property line. Okay. Now expression body will stay same. Let's say original context and wrap them to new lines. If I go for it, let's see. I need to change filter property. I need to access a property inside this property. I want to change it. I need to access reflection or inner property. In that case, sorry, I copied it. This one, filter property type, get another property inside it. Let's say property name. So this is our inner property, and I need also it means uh, equal not greater than lt. This properties I want to access filter dot h dot gt h dot lte h not is null or something like that. I want to access these properties. If you wonder wonder what I'm doing. Original context, filter property expression. Okay, inner property expression. Let's say expression dot property. Here, this is different. I don't use constant. I will use the original context dot property expression and property name. No, I don't use property name. I have already reflection info here, which is a property info. I can use the same. This is my inner property expression, filter object and value all the same. Maybe we can change the value, but I'm not sure. What is the value here? Equal itself. Okay, we can use the original value here. Value. And I can pass filter object value here. If I execute this expression over this filter object, I can access this value. So this is correct. This context isn't broken, isn't unstable. This is correct. If I evaluate this expression over this object, I can access this value. So this is correct. All the remaining is using this one. Context for my original context here. Context. Property name equal, not equal. I can pass equal as a value. Name of equal. Unfortunately, I have to do that. So what is the problem here? Name of equal. And what is the last parameter here? T value. Yeah, T value. What is T value? Okay, T is nullable. Okay. It can be null since it is a struct. This project, I didn't enable nullable reference types in this project, but this is a struct, so I have to add a question mark for it. So I think there's missing. There is missing brace. What is the problem? I have a context here. What is combined? Okay. It will be here. Okay. Now I can continue. I copy What? Strange. I will do copy and paste here. Multi, multi, sorry for that, context for. I hope the IntelliCode helps me. No, it doesn't work. What is the problem here? Yeah, the braces. What was it? GTA. Or GTE, sorry. Let's copy it again and let's make it a little bit quick. If I make a mistake, I will see from my unit tests. I trust them. Not. If I don't have unit tests, I cannot be that kind of brave to change this kind of to make this kind of breaking change. So I'm brave because I have very strong unit test for this project. Is now. Is now. Sorry. Not is now. Okay, I'll check again. What is difference? Is null and is not null. Okay, the same. The rest of them is same. Is null value. Is null value. Okay. Is null dot value. Is null itself. What is the problem? Oh, this is different. This is different because is null isn't t value t because there's no value t. We can pass it as null. Is null checks what it checks is null. Okay, it operator type is null. Is target nullable. mm, Expression body and target property, and it doesn't matter what value I sent. Okay, we can go back our operator filter. I can pass now. It's okay because it doesn't matter what value we pass. Context for is now the rest of same. This can be some difference. No, is not now. I miss some braces here. Yeah. I'll copy and continue here. What is the difference here? Yeah, I don't use this. It's not. It should be is not now. Okay. I hope we did it. Let me build it. And I want to finish it. I am a little bit tired. I will continue later. What is the change here? Build expression. Okay, this is range. We need to change the parameters here. Okay. It is expression build context. Let's say context dot body. What is body? Okay, expression body. Context dot expression body. Target property we have context dot target property. Also we have target property inside our context. Expression body, but it doesn't. Okay, it adds expression to expression body. Okay, it's not same thing. Okay, target property dot name. Target property here Perp type is nullable one of my extension method checks the type if nullable. So it's easy. I'll convert the code block again. I'll also convert this one. I'll also convert this one. And that will be enough. Okay. Setting filter. Oh, the same problem here. But before I go, not readable so much. It will not know build expression for okay. Build expression gets the expression. Build context. Okay. But the same problem happens here again. It should be same logic here. Where is our operation? Yeah, here. I need not operator filter here. I need this method, but not exactly same because it should be string property name. Yeah, it should be exactly same. I don't reuse this method for now because I'm not sure it is exactly same. So it's not exactly same. It is always string, but yeah, I will work on reusability later. So let's start refactor. Expression for, yeah, we will go with, let's duplicate this one, comment the first one, and go one by one. Context for original context, but the method problematic. Okay. Expression build context. Let's say this is context with original context we pass already. We need name of equal here because we have to access equal property, and then we can pass value here. I think it might not necessary, but yeah, we will pass the value and we can copy and apply for all of them. Not copy again and apply here, here. Where is it? Equals, equals. Yes, equals. Here. Apply before I forgot. Is not, is not, no, is not now. Since it doesn't matter the value, I can pass null instead of value. Now we can continue equals property. Yes. Let's copy and continue. This is contains. This is, yeah, compiled, but not contains. Okay, okay, I will do it later. It changed all of them for me. The italic code. So let's continue from here. Equals. This should be contains. This should be not contains. I mean, I know this is seems nonsense, but I will do that refactoring. Ends with, ends with, ends with, not ends with, not ends with. I did this manual job just once, and you don't have to do this manual job in your application again. So there can be a place to do that. So what is this? The expression by the target property, filter property, everything is same. The value is null, not null, empty. What is it? Is empty. Okay, compares for this, but okay, I can create context for context, and property name is empty. Property name is empty, but there's some difference here. I cannot do context for, or I create new expression context for it, because there is no property to compare in this case. I need to compare with the constant, real constant here. The first one is context expression y, but I think there's more than once here. I can refactor my method from here. Context for empty string. Not empty string, it's not a good name. Context for, let's say, constant. And we don't accept property name here. We just pass constant here. Inner property is, what is it? It is property info. It will be null here because there's no property. But we cannot null because there's no type. We can say there's no property info, unfortunately. But we have expression, which is expression dot constant value, which is string empty. This is by default, but okay. What is the problem here? It should be filter property expression. Okay, I told you that can be problem because we did it member expression. Yeah, we can change it. It can be expression, and we can use expression. So there shouldn't be a problem. Yeah, there is no inner property here, yeah, because we use constant. But in that case, and when our build expression, yeah, here, this method, I need to go to implementation. With comparison, not comparison. Okay. Okay, I can remove the comments here. What happens? It calls with method. Calls with method. String filter attribute. Okay, but I'm not sure. There should be some equality. Okay, we will check with tests at the end. You can continue. Context for constant. You can pass the original context, but compare with this constant. What I don't want to use new one. It's already for default value is string empty. Maybe I can use string empty instead of creating new string always. I'm not sure. Can I define here string empty? I think I cannot. Yeah, I cannot. But it doesn't make sense. We don't have to use default value because context for constant, but which constant? I cannot use the constant where I use this method. So this is much better, passing string empty here. Also wrap entire expression method here. Wrap entire expression method here. equals what is difference expression not expression. Okay, it adds the exclamation mark at the beginning of the query, for example, like that. X dot equals means this. It adds just uh, this one at the beginning, like in this case, this should be generated when you call expression not. So it's not equal to empty. Okay, so that means the rest of them is same. What is the problem with combine with? It says sorry. What is this brace for? What is this brace for? Or not? Okay, I'll change this one. Expression not. Okay, I'll just wrap is empty, not empty. True, false. This true echoes this false. But okay, it can be acceptable. Query can be true for is not empty, or query can be false is not empty. Okay. It's logical. Okay, I don't make any change for it. It's acceptable. Uh, yeah, constant. I will copy this one. I will copy this one again about this release here. Okay. I hope it is finished right now. We all succeeded. Oh, that's fine. Let's continue. Let's run our test. Sorry, actual query. Yeah, there's no problem here. Okay, we didn't achieve what we want. Let's check one by one. Actual query. Yes, debug it again. Okay, this is the extension method passes to filter base. Now we are in filter base. Let's continue. We call build expression. Now everything begins here. Get properties. We have type. Okay, given name filter object. We have only one single property, which is given name. Let's continue. We get value of given name, which is something like that. Given name and some width. We had an expression. Yeah, this expression worked. Value of this object and given name. Yeah, everything is correct. It's not null or is not ignored. We check attributes. There's no attribute on it. If there is no attribute, at the default compare to attribute, which is with the same property name for entity. And let's iterate attributes. We have only one attribute here, and this attribute have only one property name to match. Let's continue. We have target property, target entity type. Let's check entity type is preferences. Yes, in our from our tests, and yeah, we checked there's property in the entity, so we can continue. We created a body parameter here. What is body x, which is x, and we will add lambda. Build expression for property. Yeah, everything happens here. I am navigate into this one, and not this one. Navigate into this one. Build expression for property. So let's check our context parameters are correct. Expression body is x right now. Yes. Filter object is object itself. Property value, yes. Property is given name. Expression is right, correct. Let's continue. It's not null. So if it's not null, okay, we'll just create and return. What is this attribute? Yeah, there is no attribute. Okay, build default expression. Yeah, there is no custom type and there is no custom attribute. So we can execute the default expression. Everything happens in here. While we execute the default, if it is another filter, no. So there's a problem here. Filter object is seems like another filter, but it's not another filter. We have to check if the value is another filter. Yeah, you can see this is the problem. Context value. Yeah, we can run our test again. Before I go, where did we stop? Here. I'll add another breakpoint here. Okay, I'll just continue here. Build default expression. Okay, here it is not another I filter. It is a string value. Now it should go is filterable type. It's not any specific filterable type. If it's collection, it's not. Then it can apply equal comparison here. I missed it. Okay. Let's see what happened to it. Expression. What is the expression here? Given name equals. This is filter object. You can think about this filter dot given name. Now, I think we did it. Let's go back. Let's go back. Let's go back. An actual query and expected query. They should be same right now. Yeah, they are not exactly same, but we did what we want because we access here as we access here to a local variable, but in our code we don't access a local variable, we just access directly this object. Yeah, you can see value expression here, value parenthesis value, and I don't know, this magnifier work for screen recording. I hope you can increase quality of video a couple of, for a moment. We can see the difference, but we achieve what we want. But I'm not sure how can I check this is right or not. You can see that given name. There's no code string here. We achieved what we want, but this assert should work. How can we check this one? Maybe we can check there's no code inside the expression. I know it's not a best way to check, but if there's no code, then it's okay. There's no constant string inside the query. Let me check. Yeah, if there's no code char inside the query, then it's okay. Assert, let's say, should query. Do I have shouldly? Yeah. Let's assert true if actual query has doesn't have, let's say, contains. Sorry, I'll just use escape operator here. Actual query, but it's queryable. I will access expression and then it's a string, and it shouldn't have this quote because I don't want string expressions inside my lambda. Assert contains. Yeah, this is better. Okay. Now our test will work perfectly. Then we don't need expected query because we don't expect any query. We just want ignore codes inside the query. I will pass, pass and go back our test. Go up. Okay. Then you can see in this query, I cannot make it bigger, but I think here, there's no code inside my query right now. Sorry. Because it checks contain, not contains. There not contains, not contains, not equal, does not contain, or something else, does not contain. Yeah, it shouldn't contain the code. Let's refactor a little bit. We don't need actual query, and then run it. Yeah, I will just continue. Okay, go up, go up, go up, go up, go up, and we can continue here. You can see actual query doesn't have any code, and when I continue, yeah, the test is passed. We achieve what we want here, like filter.name, but uh, probably we can broke some other tests. Let's run all of them. Okay, what is the problem? How did you build? Okay, this is another library which is AutoFilterer.dynamics operator. Okay, we can skip these tests. Okay, let's go test explorer. I will just run only AutoFilterer tests. Okay, this is not topic of today. Okay, everything worked, but some of them doesn't work. You can see some of cases. We broke some of cases. Let's see. Some of them is working as expected. Some of them is broken. You can see. Okay, we just broke is not null is null. Uh, this kind of queries. We can fix it, but today we accessed, we achieved what we expect here. Also, I'm a little bit tired. We will continue later, but we finally did it. I think we did some mistake while refactoring it. So in the next session, we can complete this. We can make those tests completely working, and then I can create my pull request and merge it and release a new major version. Also, this is a breaking change. Maybe we can release a version 3 or something like that. So thanks for watching. If you are watching today, that's it. We just make this test passing, but we just broke something else, and we will look them later. Look them in the next session. You can see query is broken. Also, all the tests explain itself, so you can fix them easily. Okay. Also, same for string filter greater than is broken. Okay. Thank you for listening. Uh, we will do them in the next session. See you.